These are your 9.1b notes on graphing quadratic functions. So yesterday, or in section 9.1a, we spent time just analyzing all of the other parts of the quadratic function, but we didn't quite graph it yet. So today we're going to use those parts to create the graph along with a t-table. So if you understand how to make a t-table, you pick an x value, you plug it into the equation, and it gives you the y value, you should be all set. So to graph, we're going to find the equation of the axis of symmetry. Remember, that involves x equals negative b over 2a, and that's a vertical line. So we can use that vertical line in symmetry to help us graph. It also gives us the vertex, or the first coordinate of the vertex. So those two numbers will match. To find the y coordinate, you plug that value in to the equation, and it gives you the y value. The y-intercept is 0c. It's from the equation. And then you use symmetry to find the additional points. And you're going to connect the points with a smooth curve. So when we do this, I require that you use 5 points. But if you're smart about these 5 points, it will even seem like 1 point besides the vertex. So 2 or 3 points, just depending on how well you do with this. So we're going to make a table of values. And since the vertex is the middle point of the graph, I'm going to put it in the middle of my table. Now, some people don't do this, and tables don't have to be in order, but I think it helps with the symmetry idea. So since the vertex is that middle point of a graph, I like to put it in the middle of my table. And then we need 2 points that are on the left side of the graph, and then 2 points that are on the right side. So what's going to happen is, if we're lucky, we'll find a point on the left, and we'll know that there's a matching point because of symmetry on the right. And so these 2 ordered pairs above it would be to the left, and these 2 ordered pairs that we're going to find are to the right. Okay, again, when you make a table of values, you pick an x value, you plug it into the equation, and then the equation gives you the coordinating y value. So I need 5 total points, and then we just connect them. So this first example is the same example from the notes before. I just went ahead and I put in the information that we found yesterday. So we have an axis of symmetry is x equals negative 2. That was found using negative b over 2a. We also use that value for our negative 2 for our vertex. You plug in negative 2, you get 6. And then we get the y-intercept from the equation, 0, negative 2. We need to make a table of values. And we're going to use symmetry to graph. So our vertex is at negative 2, 6. And so at negative 2, 6 is my vertex. So I'm going to put that on my graph. I need to have at least 6 high. That is my maximum. So all the rest of my graph can go below. So what this does is it makes me at least make my, I need at least 6 points above. If I went too high, then I can always add on. So if we run out of boxes, we can always add on. But I count 1, 2, 3, 4, 5, 6. I'm right at the top of my graph here. Okay, so negative 2, 6 is right up here on that line right here. And actually, what I might do too before I begin is I'm just going to graph my x-axis, or my axis of symmetry, x equals negative 2. So that's my axis of symmetry, x equals negative 2. By making it dotted, it tells me it's not part of my graph, but it's helping me graph. Then I put my dot on it. My vertex should land on that axis of symmetry. If it doesn't land on there, you did something wrong. So from there, we know it's going to open down because it's a maximum, and that we have a negative a value. And then from there, I need to find some more points. One of the points that I already have is this y-intercept. My y-intercept is 0, negative 2. So 0, negative 2 is right here. And that's 2 units to the right of my parabola. So I'm actually going to skip the 1 ordered pair that would go here. And I'm actually going to leave room for it, but I'm going to put 0, negative 2 down here. It's the second point to the right of the vertex. Now, I don't have to pick 0. I could use any point I want to the right of that axis. But it makes sense. Why do more work? If I can use the y-intercept, I will. So 2 points to the right of my vertex gave me 0. And so if I go 2 points to the left of negative 2, I'll be at negative 4. And because they're both 2 units away, this is 2 units away, and this is 2 units away, they're going to give me the same y value. So I don't have to plug anything in. I'm going to use my y-intercept. If 0 landed at -2, 4 also has to land at -2, or -4 has to. So I found -4, -2, not by plugging -4 into the equation. I could, and I'd get -2, but I use symmetry with the y-intercept. So it's just a little bit easier to find that way. Now I need to find 2 more points, and I just decided I'm just going to go 1 in from that. So I want to find out when x is -1. So when x is -1, I want to know what point I'll get. And I know it'll match when x is -3. So again, I'm using symmetry here. I'm kind of color coordinating my points. -3 is 1 unit to the left of the vertex, and -1 is 1 unit to the right. So because these 2 points are the same exact units away from the vertex, they will be symmetrical. So when I calculate them, I only have to calculate using either -3 or -1. I don't have to do 2 separate points. So symmetry is nice because I know we need 5 points to graph, but I'm really only plugging in 1 if I use my y-intercept. So looking at those 2, I'd rather use -1 because it's just easier to calculate with. So I'm going to go up to my equation up here and do exactly what we did when we found the vertex. Y equals -2 times the -1 squared minus 8 times -1 minus 2. Y equals -2 times 1, because -1 squared is 1, plus 8 minus 2. And when I do this, you could use your calculator too. Y is equal to -2 plus 8 minus 2. When it's all said and done, -2 plus 8 is 6, and 6 minus 2 is 4. So when x is -1, y is 4. And that also means that when x is -3, y is also going to be 4. So -1, 4 is an ordered pair. And -3, 4 is an ordered pair. So you can see my dots. My blue dot is my vertex. It is the highest point. Notice that this 6 is the highest value. That means my range is correct. All the other ordered pairs go down from there. I don't go any higher than 6. The next 2 that I picked were 4. The next 2 I picked were -2. The further I go away from the vertex, the further down that parabola is going to go. So you don't have to pick these particular x values, but they're probably the easiest ones to pick. So now all we do is we finish our graph by trying to do that UV, and we kind of go beyond those points. So we connect and extend, and we try to do it in that UV shape. And there's your graph. Okay, a little weird. I know we're kind of winging it. We can't be perfect. Let's go ahead and try another one. So again, yesterday, we did this information already. We gathered all this information yesterday. It is the same as yesterday. So if you want to take a minute to fill in the spaces, it's just what we did before. This time, though, the graph is going to open upward. And I need a y-intercept of 0, 8. So I kind of want to be down below. I know that my range is telling me based off of my vertex, I won't go any lower than -1. -1 is the lowest number I'll have. So that kind of tells me that I can put my x-axis way down at the bottom, and that leaves me all this wonderful space up above the x-axis for all my values. So I make my table of values. I'm going to put my vertex in the middle again, and that's -3, -1. I'm going to graph. Oh, I think I made a mistake there. Oh, yeah, just this should be negative. My axis of symmetry should be x equals -3. If I get that wrong, everything will be wrong. And I know my vertex has to lay on there, which it does. -3, -1 is right here. There's my vertex. I'm also going to use my y-intercept again. It's 3 units away, so it goes all the way up to 8. I really don't want to go any higher than that. So 0, 8, I'm going to graph it, and you can see 0, 8 is to the right. So I'm going to put 0, 8 down here as my second point on my right branch. It's 3 units to the right, and so it matches negative 6, 8 to the left, because that would be 3 units to the left, and it's going to match up with 3 units to the right. So those two order pairs I have just based on the y-intercept. If your vertex is your y-intercept, you miss out on that. You just got to do a little bit more work. Then we need to pick 2 more points. And so I'm going to pick, you can go right next to it. The more you go out, though, you get a little bit more shape. So rather than going just 1 unit away from the vertex, I'm going to go 2 units away. So I'm actually going to look at negative 1. And if I go 2 units to the right, 2 units to the left would take me to negative 5. There's nothing wrong with picking negative 2 and negative 4. There's nothing wrong with going with 1 and negative 7. Just the further you go away, the bigger the numbers are going to get. So the closer you are to the vertex, so you kind of want to get away from that vertex a little bit. That's why I went with negative 1 and negative 5. So these two are the same distance away from the vertex. The y-intercept and negative 6 were the same distance away, so I can use symmetry. I can either plug in negative 5 into the equation or negative 1. Negative 5 is going to give me really large numbers, so I think I'm going to stick with negative 1. So when I plug negative 1 into the equation, I got y equals negative 1 squared plus 6 times negative 1 plus 8. Y equals 1 minus 6 plus 8. Y equals 1 take away 6 is negative 5 plus 8 is 3. So y equals 3 for negative 1, and so that means y is going to equal 3 for negative 5. So negative 1, 3, negative 5, 3, and if you look at your graph, you have symmetry. You just connect and extend, kind of round out those curves, do the best you can. As long as you have your table of values and you try to hit them and everything looks right, it's fine. Okay, this is your first time graphing something a little crazy like that. We are going to skip this one again. So your lesson summary is how many points are necessary to graph a parabola, and then I actually want you to graph this parabola. Now this one's a little tricky. You're missing the b value, which means you won't be able to use that cool symmetry with my y-intercept. You'll have to find more points. So you're actually going to have to plug in 2 points to get all 5. Good luck.